You already know what happens when you flip a light switch. It gives you the choice to turn the light on or off. But what happens when you move the switch to where it's right in the middle? Okay, in reality, nothing fun happens, but it's still worth exploring this. Let me show you that you aren't limited to the two options you see every day. It's not just on or off. There's a third state, and this third state is actually what allows your phone and laptop to work. You know RAM, right? The stuff that just quadrupled in price? It uses this idea. So at the end of this video, I'll show you how you can make your own 16 gigabytes of RAM. Since all these AI memes are getting stale, you can now close Instagram Reels and spend your time building RAM from scratch. So here's the idea. When we turn a switch on, a few things are noteworthy. It allows electricity to flow, but what's more important to note is that you haven't liked the video yet. Go ahead and do that real quick. Okay, back to the circuit. What's more important to note is that this wire is now connected to the positive contact of the power supply. So we can say the wire itself is on if it has a clear connection to the positive contact. Using the same logic, we can say a wire is off when connected to the negative contact. Now look at this wire. It's not off because it isn't connected to ground, and it's not on since it isn't connected to power. It's floating, meaning it is disconnected from any circuitry. So at this point, this wire is nothing but a cylinder of metal. Some geniuses were able to make use of this fact to handle multiple inputs to your computer. Yeah, I got this puppy working overtime. Since I have 4 different input devices here, including the mic I'm using to record this, the brain inside this computer has to manage which input to handle at a time. For the sake of simplicity, let's imagine each of these devices sends information through 2 wires. Now, it wouldn't be very clever to hand wire all the 2 wires to the CPU for each of these devices, because that can quickly become a lot of wires to handle, especially since in reality, these can be up to 32 wires per device. That sounds almost as torturous as sitting through a Joe Bartolozzi stream. I honestly don't know, I'm always fuming at the end of these. But anyways, let's try to think of a way to connect all these inputs to the same set of wires, but also have the ability to let just one device speak to the CPU at a time.
Can't we just use a multiplexer to control the inputs? It seems like you're overcomplicating this.
Get the fuck out of my sight before I demolish you.
You certainly could use a multiplexer here, but I haven't made a video on them yet, and the more input devices you add, the more complicated the multiplexer has to be. If you connect 2 switches like this, connect one of the inputs to power and the other input to ground, then we can do something really clever. If none of the switches are pressed, then this middle wire is literally disconnected from the power. It's floating. And we have a nice visual that represents this. If I add 2 LEDs to this floating wire, they basically tell us what state this middle wire is in. Right now, we can tell that the wire is floating because both LEDs are dimly lit. Right now, it's fence-sitting harder than XQC on any political topic, but it can easily collapse into one state when we press one of these buttons. And this allows us to control the information that this wire carries. If you replace these switches with transistors, that unlocks an extra level, because now you can send electrical signals which determine if we connect to power or to ground. And remember, the main advantage of transistors is you can make extra logic that allows you to control those signals. So we can make logic that only sends a 1 if the data stored in the device is a 1, and we enable that device. And it sends a 0 if the data is a 0, and we enable the device. Look, there just isn't a better way for me to show you this than through an actual circuit board. Kindly sent to me by PCBWay. If you've been getting your PCBs from any site other than PCBWay, I hate to break it to you, pal, but you've probably not been getting the best deals. And in this economy, every penny counts. Oh, what? I could have saved $10? I'm financially ruined. I told you to order from PCBWay, Gerald. Now look, they're taking your house. I mean, look how easy it is. Just go to your project on KiCad, click this plugin, and boom, straight to the PCBWay website. No adjustments needed, unless you want to change the color, which we all know is the most important part of PCB design. Then send your order in. If Gerald ordered all his PCBs from PCBWay, he'd still have a cool $500 in his account. That's just enough money to afford 1 medium Domino's pizza out here. And hey, maybe he'd have found use of their excellent 3D printing services and CNC machining services too. Thank you to PCBWay for sponsoring this video and being a long-time supporter of the channel. Make sure to order these boards from PCBWay if you want to play around with transistors too. Well, I kind of messed up the soldering on that board, so yeah, we're just gonna use breadboards instead. We can now connect multiple devices to the same set of wires. If none of the devices are enabled, then none of them output their values to these wires. Let's act like that bottom button actually does something. Now you can see these random values that are quote-unquote stored in these quote-unquote input devices. And at the top right, you can see green LEDs, which show us the final output. Notice that these final output LEDs are only controlled by one wire each. This is why this idea is so special. Not many wires are needed to control the output. So all I have to do is send one electrical signal to enable its output to the green LEDs. And just by pressing these buttons, I can select which input value I want to see on the output. If none of the devices are enabled, then none of them output their values to these wires. They are all disconnected from the circuit, and there's no limit to how many devices you can connect up here. If you connect 16 billion registers to the same 8 wires, I explained how registers work in the last video, and control their outputs using an address decoder, which is just a circuit that selects exactly one register at a time, you've made 16 gigabytes of RAM. Now, of course, this isn't DDR5 RAM. In fact, I don't even know what that means. People think that because I know stuff about these basic computers, that automatically makes me a PC building Reddit mod. There's a huge technological jump between these two things, so that's not how it works. The thing you just built is 16 gigabytes of RAM, but you'd have to code some special I/O handler for it to work with the PC. But again, it'd take you more than 500 years to wire this up by hand, even if you wired up one register every second. So appreciate the technology that goes into making this in a reasonable time, while also managing to fit it all in a space no larger than your fingernail. If you like learning how computers work at the lowest level, stripped down to the metal and silicon, then you might want to subscribe to this channel. You might also like this video up here.